This is Dr. E, and welcome to the first Chemistry of Life video. So, the first activity that we did in class was the Mystery of Life activity. And if you recall, in that activity, we read a story that was very similar to the story of Frankenstein written by Mary Shelley. In the Frankenstein story, the doctor, Dr. Frankenstein, was looking for a vital force or a special life force that he could instill into a corpse and bring it back to life. The question is there a vital force or a special life force that makes life unique and different from non living things? Well, as we discussed in class, there is no special substances found in living things. There's no mysterious life force or vital force. Now, some people might argue that DNA is a special substance, but as we progress through this unit, you will see why we say that there is no special substances found in living things. In fact, we could say that living and non living things are made of the same substances. All living and non living things are composed of matter, and we know that matter is made up of atoms. And matter, or atoms, follow the same rules of chemistry and physics, whether they're in a living or non living thing. The real difference between living and non-living thing is how the atoms are arranged. So when we look at a DNA molecule, it is made up of atoms in the same matter that your desk is made up of atoms. In fact, some of those atoms are exactly the same type of atoms. There's carbon in your desk, and there's carbon in DNA. The difference is that the atoms in DNA are arranged differently than the atoms in your desk. And the arrangement of atoms in DNA allow it to replicate itself, provide us with a genetic code, and give it the ability to pass those instructions on to the next generation. From there, we moved on to a demonstration of matter. Yes, it was a silly demonstration. There were several silly demonstrations, but it brought home the point of what matter is. If you recall, we put marbles in a graduated cylinder with water, and we saw the water level go up. We took a plastic bag and swung it and then closed it, and we saw that something filled up the bag. Obviously, it was air, and that it took up space. We also took a jug of water, and we took a cup and put a piece of paper in it, turned it upside down, put it in the water, and when we brought it back up, the paper was completely dry. So all these things were showing us that matter takes up space or has volume, that matter has mass, and that matter comes in three different phases: solid, liquid, and gas. Then we went to an activity that we called ashes to ashes. And the point of that activity was to indicate that, as we said earlier, that matter is composed of atoms, and that atoms are the smallest unit of matter that still retains the properties of an element. And we spoke about the six elements that make up 98% of all living things. Those are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And we use the mnemonic SHNOPS, CHNOPS, to remember those six elements. And again, six elements make up 98% of all living things. What do you think this has to do with evolution? Think about it for a minute. Every living thing is made up of those same 6 elements. So this actually is some evidence that all living things evolved from the same common ancestor. And therefore, we're all made from the same 6 atoms. Where do living things obtain SNOPs, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur? Well, they obtain their matter or their atoms from the earth and air. So, for example, carbon, nitrogen, and oxygen we get from the air. Sulfur and phosphorus we get from the earth. It's also very important to understand that matter needs to be recycled. There's only a finite amount of this matter, a finite amount of these atoms on Earth. And we would have run out of them a long time ago if it wasn't recycled. All right? There is not enough of this matter to supply all the organisms that lived in the past, supply all the organisms that live in the present, and to supply future organisms. However, the fact that these are recycled allows us to continue with life. So it's very possible that a carbon atom in you was once in a dinosaur. So on those mornings that you get up and you start to growl and you feel like a dinosaur, there actually might be a scientific reason for you feeling that way. Hey, in the next activity, we looked at a transparency with a butterfly and a molecule, and we asked, why do we have a picture of a butterfly next to a molecule? Well, it was to indicate or demonstrate that the levels of organization for living things begin at the chemical level. It begins with the atoms, particularly these 6 atoms, SNOPs, that make up 98% of living things. And we combine these atoms into molecules, and these molecules into bigger molecules. These molecules combine to form organelles, which combine to form cells, which arrange themselves to form tissues, which arrange themselves to form organs. These organs arrange themselves to form organ systems. Organ systems come together to form organisms. Organisms can form populations. Populations can be organized into communities. Communities can be organized into ecosystems. And the ecosystem can be organized into the biosphere. At each new level, new properties emerge. The next activity that we looked at was breaking water. We had a beaker of water and we put some electricity into it and we started seeing bubbles. So we know that water is a type of matter that's in the liquid state. Once we start seeing bubbles, we know we've created matter that's in the gaseous state. Water is H2O. It's made up of hydrogen and oxygen. When we input the electricity, we're actually breaking the water into hydrogen gas and oxygen gas. So this led us into the discussion of, well, what is an element? And an element is matter consisting of only one type of atom. Thus, an element is a pure substance that cannot be broken down into other substances by ordinary chemical means. Each type of element has a different type of atom, and different atoms demonstrate different properties. So atoms of the hydrogen element react and respond differently than atoms of the oxygen element. Another important concept is trace elements. And these are elements that are absolutely essential to living things, but are only needed in teeny tiny little minute amounts. And in class, we showed a slide of a woman with a very, very big bulge coming out of her neck because she lacked the element iodine. Right? She was actually hypothyroid. And iodine is absolutely essential, but we only need a little bit of it. It used to be a major problem in and around the Great Lakes area because there wasn't much iodine in the water. But once we started iodizing our salt and we eat plenty of salt, a problem in the United States does not exist to any great extent. All right. When two or more different, right, it's got to be different. So when two or more different elements combine in a fixed ratio, again, fixed ratio, that is a compound. So the two key words are two or more different elements combined in a fixed ratio form compounds. So for example, H2O. You have two different elements, hydrogen and oxygen, and they always combine in the ratio of two hydrogens to one oxygen. So water can be considered a compound. In nature, compounds are a lot more common than pure elements. Compounds of living things usually contain 3 to 4 elements. And those elements are usually carbon, hydrogen, oxygen, and nitrogen. It's important to understand that the properties of compounds differ from the properties of the elements because as we move up a level of organization, new properties emerge. So an example is the compound sodium chloride, which is NaCl, or commonly known as table salt. So it's a compound because it's made up of two different elements, sodium and chlorine, and it's in a ratio of 1 to 1. So we know, now that I said it, that this is table salt. Well, what is the properties of the elements? Well, sodium is a metal and highly explosive. Chlorine is a gas and it's highly toxic. Put them together in a compound and we got table salt. So you can clearly see that the properties of the compound are very much different than the properties of the elements. That's it for this lecture. Hope you enjoyed it. Have a good night.